Hey guys, this is the next part of the organic chemistry lesson. This is going to be done in two parts just because of my time restraints. And let's go. Let's dive into it. So the first thing that we're going to talk about will be the different types of organic compounds. We have hydrocarbons, alcohols, phenols, and ethers. And we have carboxylic acids, amines, and ketones. The acids and the alcohols, that part of it we're not going to talk about in this particular lesson. We're only going to focus on the hydrocarbons today, okay? All right, so when we hear the term hydrocarbons, that's something that I have introduced to you guys in earlier classes. And a hydrocarbon is simply a compound that contains only hydrogen and carbon, hence the name hydrocarbon. So that makes it really easy. If you have an oxygen or nitrogen or something else, then it's not considered a pure hydrocarbon. It has a functional group or has something else going on. So hydrocarbons will only have hydrogen and carbon there. Now, a hydrocarbon can contain single, double, or triple bonds. It can also have rings, and we're going to talk about those in just a moment, or in another lesson rather. But here are some examples. In this first one, you can see that these are all single bonds in this hydrocarbon. This one is showing you the double bond between the carbon and carbon. And remember, we're talking about single, double, and triple bonds. We're only talking about carbon to carbon bonds. Hydrogen can only form single bonds, all right? And then in this last one, we have some triple bonds between the first and second carbon here, right here. So that's just kind of what that is. But again, you'll notice that we only have carbons and hydrogens in all of these hydrocarbons. Now, a hydrocarbon can be broken down into really four categories. I'm only going to focus on the first three today and kind of help you to understand and be able to identify the different types of hydrocarbons. So the first one is the alkane. An alkane only contains single bonds between those carbons. Now, in that single bond, you can have either a straight chain, it can have some branches. We talked about both of those in a previous example, and the branches could be, 1 to 3 to 5, or however many carbons that breaks off of that. And we'll talk about the naming when we have those branches as well. The general formula for an alkane is CnH2n plus 2. Now, when you see that, you may say, what does that mean? The N just means number of carbons, all right? And so on the next slide, I'll show you exactly how to apply that. But basically, you're counting your carbons, and your hydrogen is based on the number of carbons times 2, and then you're adding 2 in an alkane, all right? An alkane is considered to be a saturated compound. And when we say something is saturated, these carbon atoms like to have 4 bonds. And I told you previously that the carbon can have a single, double, or a triple bond in order to meet that octet or to have the 4 bonds surrounding it. In a saturated compound, though, it would have 4 different atoms bonded to it. Now, and when I say different, it could be the same 4 different, 4 atoms different times. So C4, in that particular case, even though hydrogen is repeated, it's still a different atom of that particular element, okay? So that's what I mean by that. It's going to have different bonds, 4 single different bonds to that carbon. So that's what we mean when it's saturated. Now, some examples of an alkane. This is the general formula for an alkane, carbon to carbon bond. This R could be another carbon. It could be hydrogen. It could represent different things. It's kind of like the universal way to represent an alkane. All right, so remember I told you that the general formula for an alkane was CnH2n plus 2. So we'll just double check to make sure. If I have 4 carbons, as I'm showing here, 1, 2, 3, 4, the number of hydrogens that I should have would be 4n times 2, which is 8, plus 2 more, which would give me a total of 10. So when I count my hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have reached that number, 10. So I know that I have no double bonds here. I am good to go, or triple bonds. I have all single bonds. Sometimes I will give you the formula CH3H, CH2, CH2, CH3, and that's all the information, and I'll ask you, is this an alkane, alkene, or alkyne? And you should be able to just count your atoms, count your hydrogens, compare that to the number of carbons that you have to determine whether or not it is an alkane, alkene, alkyne, okay? All right, and this is another example here. You would count, and this is showing you the branch. This is showing you, we've got a couple of things coming off of different carbons, but if you were to count 1, 2, 3, 4, 5, 6, 7, 8 carbons, if you do the math, you can just double check to make sure that 8 times 2 is 16 plus 2 is 18. You can just count to make sure that we have 18 here, okay? Let's go on to alkenes, excuse me. An alkene is a hydrocarbon again, but it contains double bonds, all right? The general formula there is CnH2n. So we've accounted for a loss in hydrogen because we have added a double bond. Remember, each bond, each line represents 2 atoms. So if we have a double bond, that kind of makes sense why we're losing 2 hydrogens. So we're not accounting for it, or we are accounting for it in this general formula, and I'll show you that in just a moment. The fact that the alkanes have the same prefix as as alkanes, excuse me, this is a little bit premature because I haven't really talked about prefixes, but whether it's an alkane, or an alkyne, the prefixes are going to be the same. It's not going to change from double bonded to single bonded to triple bonded, whatever. All right, alkenes are unsaturated, and a saturated compound just means that that carbon has the maximum number of possible atoms bonded to it. Obviously, if you have a double bond, it's not going to have a maximum number of atoms bonded to it. Doesn't mean that it doesn't have 4, it just means that it doesn't have 4 different bonds to that particular carbon, okay? So they're going to be considered unsaturated. And they're typically nonpolar. All of these compounds are actually nonpolar. So some examples, this is the general formula again, it's showing you the double bond between the carbons here. Could be carbons or hydrogens or something different. Here we have 1, 2, 3, 4 carbons, and based on the CnH2n formula, we can just figure out that we should have 4 times 2, which is 8 hydrogens, and we have 2 plus 1 is 3, plus 1 is 4, 3 plus 2 is 6, wait, no, sorry, my math is all off. 2 plus 1 is 3, plus 2 is 5, not 6, plus 3 is 8, and so that lines up with what that general formula is. I'm sorry, guys. All right. And the last one that we're going to talk about as it relates to this is an alkyne. An alkyne is a hydrocarbon that contains a triple bond. All right, a triple bond would have a general formula of CnH2n minus 2. Again, we're accounting for the addition of a bond and the loss of 2 hydrogens there, okay? And I'll show you that on the next slide. They're, again, going to be considered nonpolar. And with that being said, they're typically insoluble in water. And when we say something is insoluble, it just means that it can't be dissolved in that particular substance or solvent. In this case, we're saying water. Alkynes, and really nonpolar compounds in general, need to have a nonpolar solvent or substance to dissolve that in. And so if that were the case, and one of the ways that you kind of think about that is a lot of oil-based substances. If you drop something that has oil in it, it stains and it's kind of there and it won't get out of your clothes unless you add that additional substance to kind of break down the bonds and allow it to wash away in the water. Or with the water, we know water is polar, and so it's not going to have much effect on that particular compound. So that's the reason why we tend to use nonpolar solvents to break down the nonpolar compounds. All right, if you were wondering. So some examples of the alkyne, this is the general formula. This R would be, in this case, would be a carbon, but again, it could be anything. Not hydrogen though. And here we have 1, 2, 3, 4 carbons again, and based on that general formula, 4 times 2 is 8, minus 2 gives us 6, so we want to make sure we have 6 hydrogens here. 3 plus 2 is 5, plus the 1 is 6, and I have exactly what I thought I would have there. So sometimes you would see just written as CH3, CH2, CCH, and then you can just say, okay, wait, something's missing. It's probably a double bond or a triple bond, depending on what the math works out to be. All right, so that's kind of it for this video. I have a second video that I'm going to show because of the time strain. All right, have a good one.